ODEON comes in 4 editions: Basics, Industrial, Auditorium, and Combined. Each edition comes with different features that will suit different needs. However, keep in mind that all editions use the same fast and reliable calculation algorithms, and that all editions support room acoustic simulations as well as measurements. What varies between editions are the available options to define your sources and receivers, and which results can be derived. We will showcase the differences between editions Basics, Industrial, and Auditorium. But keep in mind that all features in ODEON Basics are available in every other edition of ODEON, and that all features are available in ODEON Combined. All editions of ODEON, including even ODEON Basics, have all the tools you need to comply with the standards for ordinary rooms, open plan offices, workplaces, and speech transmission index, providing you with results for these room acoustic parameters. You can import geometries in formats such as IFC, DXF, and DWG, or directly from SketchUp with our free SketchUp plugin. For IFC, ODEON currently accepts models from Revit and ArchiCAD. While we recommend models to be as watertight as possible, ODEON can calculate reliable results even when there's a few leaking rays. And unlike other acoustic simulation software, in ODEON you do not need to specify the orientation of surfaces. You can also simulate acoustics in outdoor scenarios, which is reliable for distances up to a few hundred meters. You can define point sources with different directivity patterns and sound power. By default, point sources are omnidirectional, but the software includes directivity patterns for a speaking person, musical instruments, etc., which you can assign. You can also add your own directivity files. ODEON supports multiple formats for loudspeaker directivities such as CLF, the common loudspeaker format. ODEON can also load LOB and SPK files from ease. You can define regularly spaced sources or receivers with the tabulation tool. ODEON comes with a library of materials ready for use, which you can customize. A search bar will help you find materials by name or material number. You can assign absorption and scattering coefficients to full layers at a time or to individual surfaces. And independently, you can also add transparency coefficients and reduction indices for airborne sound transmission. The reduction indices can directly be copy-pasted from a spreadsheet. The quick estimate will provide an estimate of reverberation time using statistical formulas like Sabine and Eyring, and allows you to experiment with different materials before running a full simulation. An actual simulation combines ray tracing, image source method, and other methods. When completed, the multi-point response will show numerical results for each of your defined receivers. Additionally, there will be bar graphs, statistics curves, and spatial decay curves. You can also compare results with different sources and receivers, and between different rooms. Calculations in ODEON are extremely fast. As an example, using standard calculation accuracy in highly diffuse rooms, ODEON can calculate 100 source-receiver combinations with all results we mentioned in just a few seconds. Here, you will see the actual calculation time, with no fast-forwarding applied on the video. There are some visualization tools available in every edition of ODEON. One of them is 3D Investigate Rays, which allows you to visualize ray tracing, and is helpful to find holes in the geometry. There's also the 3D render, which is a solid rendering of the room. It can show colors that represent the shape of the absorption curve for each surface, or colors manually defined by the user. In this view, you can also place assets, which are 2D or 3D objects that represent sources or that simply decorate the room. You can also perform real room measurements with ODEON sine sweep system, and ODEON will derive the same parameters as the multipoint response for the measured impulse response. Or you can load impulse responses measured with any other software or equipment and also derive the acoustic parameters. In either case, you can directly compare simulated results against measured results. There are some quite appealing features available in every edition of ODEON other than basics. The first one is color grids, where you can define a grid of receivers across a surface and have different parameters displayed in an interpolated color map. This allows you to visualize the behavior of parameters across space. Again, ODEON's calculation engine is highly optimized. Here are some calculation times using one source. The calculation time would increase proportionally to the number of sources. When parallel calculations are involved, the number of cores has a direct impact on the calculation time. These editions come with 3D billiards, which is not only a nice way of visualizing sound propagation and scattering, but it also helps in identifying acoustic problems like flutter echo and focusing. These editions also allow you to estimate global reverberation times. These global estimates are independent of receivers, but they do use ray tracing, which makes them more accurate than the Sabine and Eyring formulas. ODEON Industrial, and by extension ODEON Combined, come with some features not available in ODEON Basics or Auditorium. The most important ones are line sources and surface sources. With line sources, we don't mean line arrays, but rather objects that emit sound throughout a long line, such as a conveyor belt, a train moving on train tracks, or a street with constant traffic. Surface sources are used to model large sources with vibrating surfaces, such as industrial machinery. ODEON Industrial and Combined also come with 3D matrix calculations, which calculates the response from each source to every other source which will act as a receiver instead. In other words, it takes all of your sources, treats them as sources and receivers simultaneously, and calculates the response of every possible combination of 2 points, without having to separately define receivers at the same positions. This comes in handy for open plan offices or orchestra simulations, where each source naturally also acts as a receiver for all the other sources. The source power estimator allows you to estimate the sound power of sources using real room measurements as reference. Compared to ODEON Industrial, ODEON Auditorium and Combined come with an even broader range of acoustical results. These editions support ISO 3382 Part 1 for performance places. They allow you to derive results for these parameters on top of the ones we have already mentioned. Additional new exclusive results are found in the single point response. For individual receivers, you will find decay curves, intensity hedgehog, decay roses, reflection density, reflectogram, 3D reflection paths, dynamic diffusivity curves, and each echo curves. There is also a tool for visualizing the coverage of individual reflectors, as well as groups of reflectors. ODEON Auditorium and Combined come with extensive tools for auralisation. This is listening to the simulated acoustics, as if you were physically standing in a position of the simulated space. For instance, you can listen to an orchestra in a concert hall or the noise in a crowded restaurant. Aside from producing auralisations for a fixed position and listening direction, ODEON has other ways to present auralisations. 360 auralization allows you to freely rotate your listening direction. The Soundscape app is an interactive web interface that allows you to compare material setups, receiver positions, and recordings assigned to sources. This runs online or offline on a web browser, so it can be shared to anyone even if they don't own ODEON. Movie auralization allows you to listen to the acoustics of the room while moving through a predefined path.
The Athenian agora and subslope. It was during the 5th century before Christ that the Athenian agora began to take shape as the commercial and civic center of Athens. Before the middle of that century, the center of public theater activities was moved from its temporary location in the agora.
This is exported as an MP4 video file, so it can also be shared with anyone. If you need to simulate a crowd or a whole instrument section, and you only have one or few recordings, ODEON's audio effects can generate multiple signals, adding slight variations in time and frequency. This gives you a more realistic result compared to simply stacking identical copies of the recording.
Equilibrar a resposta de uma sala no tempo, na frequência e no espaço não é uma tarefa simples. Equilibrar a resposta de uma sala no tempo, na frequência e no espaço não é uma tarefa simples.
You can also produce auralisations with real measured impulse responses. By default, auralisations are binaural, but ODEON also supports ambisonics. You can simulate an impulse response in ambisonic format up to the 3rd order. Then, you can directly produce auralisations on a 2D surround system. You can measure with an ambisonic microphone in ODEON Auditorium and Combined. Then, you can load a first-order ambisonic impulse response. You will be able to see the intensity hedgehog and produce binaural auralisations where you can freely change the listening direction. If you have real measurements of 2 adjacent rooms where the source is in one of the rooms, ODEON Auditorium and Combined can calculate the insulation of the partition wall between them. In these editions, you can define and model loudspeaker arrays. By entering the separation distances and delays of individual transducers, ODEON will produce the corresponding directivity pattern. This comes in handy when working with PA systems. You can also automatically calculate delays and levels for a loudspeaker system according to the Haas effect, meaning ODEON will optimize the gains of the loudspeaker system while keeping the sound localization towards the original source. In the material calculator, you can define layers of material types, such as porous layers, membranes, fluids, and perforated layers. And ODEON will calculate the absorption coefficients of the full setup, which you can then save to the material library. Finally, the Genetic Material Optimizer helps you to calibrate a room model to measurements of a real room. The Genetic Material Optimizer adjusts your material's absorption coefficients to match the simulated results to the measured results. It can also help to optimize your absorption coefficients for a target range of results. ODEON Combined includes all features we have mentioned in this video, so it will offer maximum versatility to work with a broad range of projects. You can try all features in our free demo version, which you will find on our website odeon.dk, Downloads, Free Trial. Additionally, you can find a comparison sheet under Product, Prices and Editions. For purchase inquiries and a free video call demonstration of the software in action, click on Buy ODEON and contact us through the form.